Hey guys, this is Lego Masa 99 again today, back with another video, and today I want to show you guys how to develop, program, upload, and execute um, a program written in ARCISS. And yeah, so without further ado, let's get started. Alright, so to actually develop a program for one of my Redstone computers, and in this tutorial I'm going to be showing you guys how to write a program for the Redstone computer version 4.0, and I have it loaded here. But yeah, you will need a few things. The first thing that you will need is the compiler, obviously, and I have downloaded this straight from the repository, the Bitbucket repository, which I will put a link to in the description. So we will need the compiler and an uploader program to upload our compiled code. But in this case, I'm going to be using the newer version 1.1 alpha of the DRCHLLC Uploader, which is right here for this tutorial. And you can find all of this on the repository as well. The next thing you'll most likely want to be able to program programs in the ARCISS version 1.0 language as time of recording this video is the instruction manual. Not the instruction manual, the ARCISS language manual. And you can find that on the wiki page here. So I have the wiki loaded here, so I'll just, let's say we go back to the home page of the repository. You can find it if you go to wiki, click on wiki, and then this document here, the instruction set documentation. Now this basically breaks down every single possible thing you can do with ARCISS version 1.0, and it comes very handy when you want to write code for the ARCISS language. So yeah, now that we have everything, let's go ahead and get started. One last thing that you guys will want before programming is that you want the ARCISS integrated development environment set up. And basically to do that, you will need Notepad++ right here, along with the ARCISS version 1.0 language loaded into Notepad++. And if you guys don't know how to do that or don't know what I'm talking about, I've made a separate video on how to set this up to code in ARCISS. Alright, so now that we have all the requirements taken care of and out of the way, let's go ahead and get started. So the program that I'm going to be showing you guys today how to program is just the basic Fibonacci program that you guys have seen in most of my Redstone Computer showcase videos and testing videos and compiler project videos and all that stuff. So what we're going to want to do first is that we're going to want to go ahead and basically create a new file. So I have a blank slate of Notepad++ open here. And we're going to go ahead and save this. So we're going to go save as, and let's just put it on the desktop as Redstone Computer Fibonacci program tutorial. And you want it to be a .txt file, and we're going to go ahead and save that. And now that we have our file saved, as you can see it popped up on our desktop here, now that we've had that saved, we're going to want to start off by typing in #rc compile target, exactly like this. And this essentially will tell the compiler that this text file is an ARCISS source code file. And as you can see here, nothing has been styled or highlighted, and the reason for that is because you don't have the ARCISS version 1.0 stylers loaded in. And to do that, essentially all we need to do is just click language and then click on ARCISS version 1.0. And as you can see now, it shows up as an actual statement here, and that's when you know that it's loaded correctly. Alright, so now that we have our target identifier here for the compiler, now we're going to have to basically think about what do we want our program to do. Now, essentially what the Fibonacci sequence is that it's basically the next number is the result of the previous two numbers added together. So then you end up with 1, 2, and then 3 because 1 plus 2, and then 5 because 2 plus 3, and then 8 because 3 plus 5, so on and so on and so forth. And essentially, the Fibonacci program that I've shown essentially calculates the Fibonacci sequence all the way until what's called a shift overflow, when the 8-bit buffer, or the 8-bit bus rather, in the computer can no longer store that data. And so once the computer detects that that's happened, then it'll shut off. So what we need if we think about it here, is that we need two variables to be able to store our two numbers in to be doing calculations with. So to do that, I'm going to go ahead and add a comment here. And to add comments, it's just a double slash. So I'm going to say initialize two variables to do our addition with. Okay, so just a comment, and then we can save it. And if we reference our programmer's manual here, and we look for variable manipulation, creating a new variable, and it shows us right here how to do it. New var name is equal to a number. And so we want to create two new variables. So what we can do is that we can type in new, and then let's just call it value 1. This is our first number. Or we can go number 1 is equal to 0, because we don't have anything assigned to it yet. And then our second variable, new number 2, is equal to 0. And now what this will do is that it will create two special, it'll create two variables for us to store information in. All right, so now that we have our two variables initialized here, what we're going to need to do now is that we need to basically start working on the logic part of the program. So what we want it to do is that we want it to check if adding the two numbers that it needs to add together will basically overflow the bus, the 8-bit bus. And if it does, then we will exit out of the program. And if it does not, then we'll add those numbers again and then save it somewhere. So now that we have that basically realized, what we're going to do is that we want to use an if statement. And if we go here to our manual and we look for logical statements, as you can see, we have if and then a condition in parentheses, and then brackets, our code here, and then else, and then your code here if you want an else condition. And also we have, this is what we're going to be using here, if a function in parentheses causes a condition. So this condition that we're testing for is what's called a shift overflow. And it's one of two conditions that uses the causes keyword in the ARCISS version 1.0 language. As you can see here, shift overflow and shift underflow. So what we're going to do is that we're going to tell the program, so we go if, right, start an if statement, and then we're going to want to basically have our function, so basically our addition that we want to do, in another set of parentheses here. So our function would be number 1 plus number 2 causes, and then a shift overflow, since we're testing for a shift overflow, and it has to be in all caps. And as you can see, it's been stylized, and if it's been stylized, then you know you've done it right. So this basically is saying run this calculation, and then if this calculation here causes a shift overflow, then do something. And then we need our open bracket and our close bracket here. And as you can see, Notepad++ neatly combines them together. And so what we said was that if this was true, then we want the program to exit and to stop. So essentially what that is that if we want the computer to turn off, we just type in exit and then two parentheses and then a semicolon. And we do need semicolons to end each line of code that isn't an if statement. So as you can see here, this basically now says, just to summarize, if this calculation causes a shift overflow, exit the program. All right, so now that we have this in, what if it does not equal a shift overflow? So what we can do is that to basically run code when it's not true, we can type in else and then have our brackets here. And what we want to do is that we want to basically perform this calculation, save it somewhere, and what we also want to do is that we want to put it on the decimal display. So if we go back to the Redstone Computer world, we want to run that calculation and then put it up on the decimal display here. And so to do that, what we're going to do is that we want to basically save this calculation somewhere, since at the moment this calculation does not get saved anywhere. So what we want to do is that in this case, we're going to type in number 1. So we're going to set the value of this variable equal to, and then you have to put parentheses, number 1 plus number 2. So essentially what this does, extra parentheses there, and then a semicolon. Essentially what this does is that it'll add number 1 and number 2, and then save that result to number 1. And now to output something to the decimal display, what we're going to have to do is that we need, the function for that is output, and then as you can see, it turns bolded and it's a turquoise. And we need two arguments here. The first one is the ID for wherever you want to output it to, and to find that, if you don't know it off the top of your head, we can look for the output opcode here, so IO output. And as you can see here, it's asking for the port ID and then the variable. And if we look here, we have the port ID spelled out nicely here. So 0 is the decimal display, 1 is the raw binary display, 2 is a parallel output port, and then 3, 4, 5, and 6 are the 4 computer indicators. So in this case, the decimal display is what we want to output this to. So for the first argument, for the port ID, we want to type in 0. And then the next argument is what value do we want to push to the decimal display, since we specified that with the 0 here. And we want to put the value of number 1 there. So then we just type in number 1. And then end that with a semicolon. So now what this whole block will do is that it'll check if this calculation causes a shift overflow. And if it does, we'll exit the program. But if it does not, do that calculation again, save that to this value, and then output that value to the decimal display. All right, so now that we have this first piece of logic done, what we're going to need to do now is that to run the Fibonacci sequence, we need to essentially do this again, but instead save it to number 2, to the second variable, instead of this first variable here. And that's the, I won't really get into the reason for why that is, but that is how you basically run the Fibonacci sequence in any language, is to do that. But I will show you guys how to do that now. All right, so to do this, what we're going to do is that the second logical block here is essentially the same as the first one. So we're going to go ahead and copy and paste that. But instead of number 1 here that we're saving it to, we're going to save it to number 2. And this, essentially changing it this way, allows us to have the functionality to where we have the last 2 numbers added in the Fibonacci sequence to create the next number. Because we need this here to save this value to the first number, and then this here to save it to the second, and then it'll add, and then this will basically enable us to add the last 2 values in our Fibonacci sequence to create the next value in the Fibonacci sequence. So yeah, you need an understanding of how the Fibonacci sequence works to be able to understand the logic in this program. But now that we have this done, essentially all we need to do is to just continue this until until this condition is true. And to do that, we are going to take advantage of loops. All right, so to take advantage of loops in ARCISS version 1.0, essentially it's synonymous to go-to statements in most programming languages. And so basically with the go-to statement, you would have a label of some sort before a certain line of code. So let's say we wanted like to jump to here, then we would have like a label of some sort, and then we would have, and at some other point in the program, we would have a call to jump to that label, and then that would jump to that line of code. So that is how it is implemented here in ARCISS version 1.0, and those labels, to identify a label, is to use a basically a double pound sign and then have the name of the label in the middle. So as an example, let's just go label like that. And then as you can see, it is stylized, and this is a label. Now what we want to do is that we want to initialize with these 2 variables and then run through these 2 logical blocks here until one of these conditions is true, and then it will exit out. So in that case, once it hits the very bottom of code execution way down here, we want it to jump back up to here. So because of that, we want our label right up here. And so let's just call this label, I'll call it main loop. And I use main loop there. So now that we have a label, what we can do is that we can call to jump to this label. And what we want to do there is that we want to have it jump back to the top once we hit the bottom of the program. So naturally then we would want our jump to be down here. And to basically jump back up to a label, what we do is that we run the jump function. And we type in jump, and as you can see, it's been stylized. And now, in parentheses, we just specify the name of the label. So main loop without that extra pound sign, and then a semicolon. So now what this says, this whole program, is that it initializes 2 variables at the beginning of the program, and then it will loop through these 2 blocks until one of these conditions is true here. So either this one or this condition. All right, before we finish programming here, one thing that I did forget is that we actually want to initialize this variable here with a value. So we want to initialize either number 1 or number 2 with the number 1 so that we can start actually having a Fibonacci sequence, because if we do not initialize a value to either one of these variables, then it will just add 0 and 0 forever. So we need a starting point here, which is 1, and I'm going to have that be set to the number 1's value. So we have new number 1 is equal to 1. So yeah, that will enable us to actually have a working program that generates the Fibonacci sequence for us. All right, so at this point, we have essentially finished developing our program here. Yeah, so now what we're going to want to do is actually compile it and upload it to our Redstone computer target, which in this case is the Redstone Computer 4.0, and actually execute the program and see how it runs. So to do that, we will no longer need Notepad++ here, and we will no longer need the programming manual, so we can get rid of those two things. But now we're going to need the compiler. So if we open up our folder here that has the revision 1.5 alpha of the compiler right here, what we're going to need is that we're going to need to compile this. So to do that, we're going to go ahead and specify our target file. That's the text file that we just created. We're going to want to specify the target, the Redstone computer. So that's ID2 Redstone Computer 4.0, and then the core 1, just for now. And I'm going to go ahead and specify debug just to show what's going on. So now that we've done that, it will break down the arguments that we've just typed in, and then it will, if we let it run, it will let us, or it will compile that program for us. And now that that's done, we can go ahead and take a look at the compiled program binary, and it looks something like this, as we can see here. All right, so now that we have our compiled program binary file, all we need to do is upload it. Now I'm going to be using the latest revision of the DRCHLL Uploader, which is version 1.1, and I'm going to be using the data pack uploading method just because it's so much faster. So what we're going to want to do is that we're going to want to open up our uploader, pass in the program binary file, and specify our target and our core, and you have to make sure that these match to what you passed into the compiler so that the machine code is uploaded to the right spot. And then I'm going to specify debug just in case, and I'm going to turn on cleaning the core first and then uploading our program to it, and you can do that with -09. Now that we've done that, when we run the uploader, it will generate a data pack for us just like that very quickly. And now we just need to go ahead and install this data pack here to our Minecraft world folder. Alright, so installing and actually running this data pack is super easy. So what we're going to do is open up our Minecraft save folder, which is right here in .minecraft, and then go to our saves folder, choose the world that has our computer target in it, go to data packs, and then drag this folder in there. And now once that's done, we're going to load up our Minecraft world and then type in /reload to reload all of the data packs and to load in our uploader data pack here. And we're going to take a cow spawn egg out of all things, and we are going to essentially upload it here. So I'm going to go ahead and go boom like that, and as you can see, it started and it finished. Now I already had the Fibonacci program loaded in here, so you didn't really see anything change. But if this was a clean core, like I've shown in a couple of my other videos showcasing and explaining the uses of the uploader, it does actually upload all the stuff here instantaneously like that. Alright, so if you were actually writing a program for these Redstone computer targets like I just did and I showed you guys will obviously want to debug your program and make sure everything's working, because it is very unlikely that once you upload the program it'll work when you just click on, because there's either you've done something wrong with programming it, or it doesn't do what you wanted it to do, or maybe the computer's running too quickly. So a couple of debugging tips that I will give you guys is that, first of all, once you've uploaded a newly compiled program that you just wrote, I would go ahead and run the computer at the slowest speed possible. And to do that, essentially just flip down the switch for the Redstone Computer 4.0 to basically load in a new speed value. And then if we just put in 111 here, this is the slowest the computer can run. And then if we flip the switch back up, it'll save this speed value. And what this essentially does is that it takes out speed out of the equation for your program. so that if your program executes correctly running at this speed, then you know the program actually works, and then you can start to eventually decrement the speed down until the program is unstable, and then that speed is your fastest speed that you can run the program at, for example, on this Redstone computer version 4.0. All right, so what happens if you've changed the speed all the way up to the highest speed possible and the program still doesn't work? Well, then this is a bigger indicator that means that your program may not have been programmed correctly, or something went wrong when you were developing it, or it's not working the way you intended it to work. And to address that problem, there is a debugger center. So if we go over here, fly right down here, there is a debugger center right here. And I will show you guys how to use this and give you guys a quick rundown of it. All right, so when you're manually debugging your program, you're also going to want your source code file. So let's go ahead and pull that up. So we have our source code file right here, along with our Minecraft window. And I'm going to go ahead and pull these up side by side. So let's go ahead and shrink this down, and also shrink the Minecraft window down just like that. Okay. So this basically allows you to manually increment lines of code to make sure that every line of code is running the way you want it to. So to do this, to use the debuggers mode, first of all, you're going to want to enable debug mode. And on the Redstone Computer 4.0, that's this little switch right here. And then you're going to want to manually turn on the computer. And you also want to make sure that you have the right core loaded. So we uploaded the program to core 1, so core 1 is on, which is perfect. And now we can go ahead and manually initiate the computer, turn it on. And as you can see, it's telling us that debug mode is enabled. And now that the computer has been initialized, you're going to want to copy the command inside of this block here, because this will allow you to fly anywhere in the hardware and paste that command, and this will manually increment the line of code for you. And now that the computer is initialized, we need to basically run it once. We need to run the computer because to load the first line of code into memory. Since as we can see here, line 1 of code is selected, but it is not loaded. So to load line 1 of code, you're going to want to paste that command in. And then as you can see, it has clock, and then all of these registers update, and now we have data in here. And now let's just make sure to compare that. So since we're on line 1 of code right now, line 1 of code is loaded into these registers. We want to make sure that the computer is actually doing what we told it to do. So the first line of code here, we said new number 1 is equal to 1. And now essentially, since variables are just pointers to locations in memory, we're going to go ahead and take a look at the RAM, the random access memory. And if we look here, we have this is off, which means that line 1 is being, or actually no, RAM 2 here is being updated with data, and it is being written, a value of 1 is being written to it. I know this because I developed the computer myself, but yeah, so I can tell here that a value of 1, since this is the 1 bit, and this is the 2-bit, 4-bit, 8, 16, 32, 64, and 128. And that is being loaded into RAM address 2. So the compiler has picked the variable number 1 to be the location in memory RAM address 2 here. All right, so now we've basically confirmed that the computer is doing what we told it to do for the first instruction. Now you want to check the second instruction here, which is new number 2 is equal to 0. So to basically increment the line of code, we can just paste this command in, and it will clock that for us. And now if we wait a little bit, as we can see, something has changed. So now we have a value of 0, because there's nothing on here, being written to RAM address 3. And so this tells us that the compiler has picked RAM address 3 as the memory location for this variable number 2. So now we can also confirm that the program has written a value of 0 to the variable number 2. All right, so now that we've confirmed that the second instruction works, let's check the third one. So if we go ahead and load the next instruction in, something else changes, but you might not know necessarily what. So if we look here in our program, we can see we have a label here, main loop, but then we have here, if number 1 plus number 2 causes shift overflow, then exit. So what the computer will run first is everything in here. This includes multiple functions, singular functions, all that stuff. So since we know that that's going to be running an addition operation, we would want to check the arithmetic logic unit of core 1. And essentially that is up here. That is this core. Let's see here. This is kind of like a debugging tutorial too, more than the development tutorial. So you have core 1, 2, 3, and 4. So this is core 1 in here, and you want to check the arithmetic logic unit because that's what does all of the mathematical computations. So we have here number 1 plus number 2. And now if we think about it, these were just initialized with values 1 and 0, so this should be 1. So if we look here, and right here, this special register right here is the ALU output register, and it is outputting a value of 1 if we look right here. This is the ones place, or the ones bit. And so the ALU is outputting a value of 1. And another way to check that it's doing the right thing is that if we just go a little bit down from here, I have conveniently labeled all of the operations that the ALU can do and is doing right now. So if we look, we have a line here, and the add line is high, so it's on. So basically we can tell that the ALU is doing an add operation and the value is 1. So since we can tell that, we can confirm that this is working correctly. And yeah, basically by stepping through every single operation that your program does here, you can basically debug line by line of code to see whether the computer is executing the code that you actually meant it to execute. And then we also have line of code indicators up here to tell which line of code the program is on to aid your debugging experience. So I won't step through every single line of code in our program here just because that would take way too long. But for more information on the specifics of like the computer hardware to ease your debugging experience, you can check out the Redstone Computer 4.0 and 3.0 if you're programming on a 3.0, the breakdown videos, because in there I explain all of the major components of the computer, and it'll give you a hint on what you should check when you're basically debugging your program. All right, so I have essentially debugged this program already, and I know it works. So what we're going to do now is that let's just say that we finished debugging and we know that the program works. So we're going to go ahead and turn debug mode off. This is very important. And to do that, just simply flip the switch, and now the debug mode is off. And now that we've debugged our program successfully, and we know that our program works at the lowest clock speed, we can essentially start to decrement the clock speed until the program works successfully. All right, so now that we've written our program in ARCISS, we've compiled it, we've uploaded it to the computer, and we've done debugging on it, and now that we know that it works, we're going to go ahead and run the program and just see how it runs. So the computer is on right now, so we're going to go ahead and turn it off from the debug session. And once we hit off, it should do a bunch of reset stuff, and it's lagging a little bit. And when you're doing any big operations with the computer, make sure that you wait for this value here to hit 0 with the chunk updates, because if there's chunk updates, then there's most likely redstone moving around in the computer, and you don't want to run multiple operations at the same time unless you're running a program. So let's go ahead and turn on the computer, and it will show you guys that our program does work. Alright guys, so we just saw there was the full running of the program, and actually I had to increase the speed up by one value compared to what I thought was the fastest speed, and that just goes to show you that you know, debugging your programs is important and everything, and that speed is a factor in whether your programs execute correctly or not. And yeah, so now that we've developed the program in ARCISS. We've compiled it, we've uploaded it, we've debugged it, and now we've ran it successfully on here. That's pretty much it. Yeah, alright guys, so that is it for this video. I hope you guys enjoyed it, and hopefully it gave you guys a little bit more information on how the ARCISS language works and how the whole development cycle for these Redstone computers essentially works. So if you guys have any questions, please make sure to leave them in the comments below. And yeah, other than that, have a good day, guys. Bye-bye.